This video is to help you prepare for your 2D quiz. You are answering the questions that are in your notebook and we're working the problem that is titled At the Arcade. This video may be pretty long, so just fast forward to the questions that you're having trouble with or to check your answers. You don't have to listen to every single word of this video. So the problem is Ron has a player's card for the arcade at the mall. His player's card keeps track of the number of credits he earns as he wins games. Each winning game earns the same number of credits, and those credits can be redeemed for various prizes. Ron has been saving his credits to collect a prize worth 500 credits. The table shows the number of credits Ron had on his game card at various times today when he checked his balance at the arcade. Number 1. Explain the meaning of the ordered pair 0, 120 listed in the table. So he wants 500 credits at the end of the day, and they want us to start out by describing what does 0, 120 mean. Well, 0 is representing the number of games he has won at that point, and 120 is representing the number of credits that he has earned. So the point 0, 120 represents that Ron started the day with 120 credits. He hasn't actually played any games today, but he has 120 credits they left over from the last time. Number 2. Write a rate to compare the change in credits earned to the change in games won. Show your work. They want a rate. A rate is a fraction, and they want us to look at the change in credits. Remember that triangle means change in, and they want us to look at the change in credits compared to the change in games. So I'm going to real quick write a piece of that table. You don't have to write that. And we're going to look at the change in credits divided by the change in games. Well, the change in credits, I go from 120 to 216. So we need to subtract, and we get 96. Then I'm going to look at the change in games. I go from 0 to 12. So 12 minus 0 is 12, and that's my denominator. And we want to put our label. So this is 96 credits per 12 games. That is our rate for number 2. Number 3. Write the rate as a unit rate and explain its meaning. So a unit rate is whenever 1 is the denominator in your rate. Okay? So this is what we left off with on the last problem, 96 credits divided by 12 games. I want to know how many credits is it for one game. So to go from 12 games to one game, I had to divide by 12. And I'm going to do the same thing on the numerator. 96 divided by 12, and that's 8 credits. So what this means is that he earns 8 credits per game. Number 4. Recalculate the unit rate by using different values from the table. Show your work. So for number 4, they want us to recalculate with different numbers. We can't use the numbers that we used on the last problem. So I'm going to take a look at a different part of the table, and I'm going to remember that we did change in credits over change in games. So we're going to start with our change in credits. From 264 to 320, we're going to subtract 320 minus 264. And then I do the same thing with my games column. Go from 18 to 25. So I'm going to subtract 25 minus 18. Now to get to 320 quickly, if I added 6 to 264, I would get 270. And then I'm only 50 away from 320. So I know that it is, or that 320 minus 264 is 56. And then 25 minus 18 is 7. Okay, so we've got 56 divided by 7, which is the same thing as 8 credits divided by 1 game. And what's interesting about this is that it's the same unit rate. That's important. Okay, it's not changing throughout the day. All day long, it's the same rate. Alright, number 5 says analyze Rhonda's calculations shown and explain to Rhonda why her calculations are incorrect. So we know that this is incorrect. She has something along the lines of 444 credits divided by 40 games, and she thinks that that equals 11 credits per game. And her justification is, I used the last listing in the table and wrote a rate, credits per games won. Then I divided both the first and second terms by 40 to write the rate as a unit rate. I got 11 over 1. The unit rate is 11 credits per each game won. So her reasoning sounds to make sense and seems very similar to what we've been doing, but Rhonda didn't consider the change in each value. And the reason I say this is because Ron starts with 120 credits. So he did not earn 440 credits in 40 games. So you have to take into account the change that's happening between 120 and 440. You can't just use the last value. Alright, number 6. Before Ron started winning games today, how many games had he won for which he had saved the credits on his player's card? Show your work. Let's make sense of this question real quick. He has 0 games and 120 credits, and he get 8 credits per game won. Now 120 credits, we want to know how many games did it take for him to save 120 credits. So we're going to set up a ratio here. 8 credits equals 1 game, 8 credits divided by 1 game equals 120 credits divided by some amount of games. And we want to find out, what did we do to the 8 credits to get 120? We're going to multiply it by something. So I need to do the inverse of multiplication to figure out what I'm multiplying 8 by. So I'm going to do 120 divided by 8. 8 goes into 12 one time. That 1 doesn't represent 1, it represents 10. So 10 times 8 is 80. Then we subtract, and we're left with 40. 8 goes into 40 5 times. 5 times 8 is 40. We subtract and get 0. So we know that we need to multiply the left ratio or rate by 15 to get the right or the correct answer of number of games. So 1 game times 15 is 15 games. So it took 15 games for him to save 120 credits. Number 7. After Ron won his 40th game today, how many more games does he need to win to collect a prize worth 500 credits? Show your work and explain your reasoning. So again, we're going to start by making sense of the problem. They're referring to the table where it says 40 games equals 440 credits, and we want to know how many more games does he need to win to get to 500 credits. So we want to know the change between 40 and some number that gets 500 credits. There's a couple of ways that we can do this. So first, let's look at the difference between 440 and 500. So 500 minus 440 is 60. He's 60 credits away right now. So I can set up a rate to figure out, well, how many games does he need to play to get 60 more credits? So I need to know 8 times what is going to get me to 60. Well, I know 8 times 8 is 64, and 8 times 7 is 56. So I can't play half a game, okay? So we're going to have to pick the higher number here to get us past that 60 credits. So it's approximately 8 games. Okay? He needs 8 games to finally reach that 500 credit mark. He's going to have a little more than that, but that's okay. That's one way that you can solve this problem. Another way that you can solve this problem is by looking at 500, which is what he wants, minus the 120 he already has. That gives you 380. Then you write your rate up using 380 credits. And when you do this, you have to take 380 and divide it by 8. So 8 goes into 38 4 times. That 4 represents 40. So 40 times 8 is 320. When you subtract, you get 60. 8 goes into 60 7 times. 7 times 8 is 56. When you subtract, you get 40. And then 8 goes into 40 5 times. So you get 47 and a half games total is what he needs to play to get to 500 credits total. Okay? Well, you can't play 47 and a half games. So we're going to have to round up to 48 games. That means inside this yellow square, he needs to play a total of 48 games today. We want to know how many more games. If he's already played 40, how many more games are there? So we have to take 48 minus 40, and we get 8 games. Either method gives you the same answer. It's just kind of how you think about solving the problem. Alright, number 8, create a graph to represent the information from the previous table. Include scales and labels. You will need to tear out a piece of grid paper and tape it onto this page so that you can create a graph. Your graph should have an X and Y axis with arrows and labeled X and Y, and it can look something like this. You can pause and count the size page you would need or piece that you would need. But once you've got this set up, then we add a title, and I'm just going to call it Ron's Games. I'm going to label my X value with the variable that is being represented by X, which is number of games 1. And then I label my Y axis with the variable that Y is representing, which is number of credits. And now I have to label my X and Y axis. And I'm going to use the table to see how far I need to go. So I need to get to 40 on my X axis. The only rules that you have when labeling is make sure that each grid line represents the same amount of distance, and that you get to the 40 that you need to get to. So I'm counting by 2s, but if you recognize, or if you take a look and see, it looks like I'm counting by 4s, but every grid line is worth 2 games. Make sure that you have them evenly spaced. For number of credits, I need to get to at least 440. So on my graph, I'm going to count by 30s and get to at least 440. And again, it looks like I'm counting by 60s, but I'm actually, each grid line is worth 30 credits. Okay, once you have it set up like this, then you can start plotting points. Our first point is at 0, 1, 20. Our second point is at 12, 2, 16. Our third point is at 18, 2, 64. Our fourth point is at 25,320. And our fifth point is at 40,440. So go ahead and use a straight edge to connect your points. Make sure you have an arrow, because that line goes on forever. The more games he plays, the more points, or the more credits he'll have. That's our graph. Part A says, does the graph represent a linear function? Explain why or why not. Well, linear has the word line in it, so it is linear because it's a straight line. And it's a function because each x value has only one y value. Part B says, to calculate the rate of change from the graph, show your work. So the rate of, I'm going to use some points here. We have 40, 440, and 0, 120. The rate of change is the same thing as slope. So rate of change is going to be rise over run. I'm going to rise up from 140 to 440, and that's 320. And then I'm going to run over from 0 to 40, so that's 40. And 320 divided by 40 is 8 over 1. Number 9. What is the domain of the problem situation? Include units in your response. Well, the domain is the x values. So we need brackets around this, and it's 0, 12, 18, 25, and 40, games 1. Number 10. What is the range of the problem situation? Include units in your response. So the range is the x values. We need brackets around these, but it's 120, 216, 264, 320, and 440 credits earned. Number 11. What is the unit rate of change modeled in the graph? Use numerical values and units. State whether the rate is of increase or a rate of decrease. So I'm going to rewrite what we put on the graph earlier, so you don't have to write this down because you've already got it written down, hopefully. But this is how we found our rate of change. If I rewrite this unit rate, 8 over 1, using units, then I get, oh sorry, it wants us to increase or decrease. So then I get 8 credits per one game, and then as I play a game, my credits increase. So this is a rate that is increasing, and because our rate of change is positive, it's a good indicator that it's an increasing rate. Number 12. Write in sentence form what is happening in the problem. Include the initial values of the independent and dependent variables in the context of the problem, a sentence explaining the rate of change in terms of the context of the problem, and the final values of the independent and dependent variables in the context of the problem. So we want 3 sentences here so that we make sure we hit all 3 requirements. The first one is, when Ron arrives to the arcade, he hasn't won any games. However, he has 120 credits, remember, because he saved some before on a previous visit. So that's the first piece of criteria. The second one, he earns 8 credits for each game won. And the final piece is, he needs to win a total of 48 games to have a total of at least 500 credits. I hope this helped you prepare for tomorrow's quiz. Don't forget our study session the day of starts at 7:30 and you're more than welcome to show up. Thank you.